This is the review for AP Chemistry Unit 2, and these are the topics. First is about the electron. The Heisenberg uncertainty principle states that it's impossible to know an electron's location or speed around the nucleus of an atom. So Schrödinger predicted where the electron would be moving within each energy level, and quantum mechanical model is the electron cloud model, which shows where electrons are 90% of the time. So it looks like this, like dots around the nucleus, and it shows where electrons are most of the time. So you can predict where electrons are, but you cannot for sure know where they exactly are. Sublevels are specific areas like S or P sublevels, and orbitals are specific shapes, such as that D sublevel has 5 orbitals and P sublevel has 7 orbitals. Next is the electron orbitals. S sublevel has 1 orbital, and each electron orbital can contain 2 electrons maximum. P sublevel has 3 orbitals, so it can have 6 orbitals in maximum, and D sublevels have 5 orbitals, which can contain 10 electrons in total, and F sublevel has 7 orbitals, so it can contain 14 electrons in total. So you can see that it increases by 4 electrons. Next is the energy level. The first level, n equals 1, only has S sublevel, so it can only contain 2 electrons. So it will be like this, 2 electrons on the first energy level, and second level can have S and P sublevels. So for S sublevels, it can contain 2 electrons, and for P sublevel, it can contain 6 in maximum. So the second level, n equals 2, can contain at most 8 electrons. And third level can have 2 plus 6 plus 10, so 18 electrons. And fourth level can contain 32 electrons in maximum. Pauli exclusion principle states that one orbital only holds 2 electrons because they repel each other. So because of the repulsive forces, orbital cannot contain more than 2 electrons. Next topic is the electron configuration. So you can write the electron configuration as lithium is 1s2, 2s1. And this number indicates the energy level. So this is the nucleus and first energy level and second energy level. So it means that lithium has 2 electrons in the first energy level, like this. And then lithium also has 1 electron in second energy level as well, but it's in the S sublevel. And for nitrogen, you can see that nitrogen would have 2 electrons in first energy level and 5 electrons in the second energy level, because they're all in 2s or 2p. Aufbau principle states that electrons feel the lowest energy levels first to be closer to the nucleus. So 4s feels before 3d because it's more stable. Therefore, for K, potassium, you see that it has the electron configuration of 1s2, 2s2, 2p6, 3s2, 3p6, and then 4s1 instead of 3d. And you can count from the periodic table as 1s2, 2s2, 2p6, 3s2, 3p6, and then you see that 4s comes first. This part is 3d part, 3d sublevel, but you see that 4s sublevel comes first. So in the periodic table, D sublevel starts as 3d, which is this part, and F sublevel starts as 4f. Next is the noble gas configuration. It starts at a noble gas and add extra electron configuration. So for magnesium, for example, magnesium is here, and if you write the electron configuration, it would be 1s2, 2s2, 2p6 and 3s2. But if you write the noble gas configuration, you start at the most recent noble gas and you write neon, and then you add the extra electrons after neon, which is 3s2. And for potassium, you would choose the argon, the most recent noble gas, and then add 1 electron more, which is 4s1, indicated in here. And for CS, you would choose Xe and then add 1 more electron here, which is not shown, but this is where CS is located. Cr, Co, and copper are rule breakers because they do not fill 4s orbitals fully, but they only fill 1 electron to 4s sublevel and add 1 more to 3d. So Co has to be 4s2 3d7, but 1 electron from 4s sublevel fills 3d sublevel, so one of them goes to 3d sublevel, which makes it 3d8 instead of 3d7. And that also applies to copper and chromium as well. Next is the orbital diagram. So Hund's rule states that electrons will fill an empty orbital first, not to repel each other. So oxygen is 1s2, 2p2, and 2p4. But in electron configuration diagram, electrons will go to all 3 different 2p sublevels. You might think this electron was supposed to be in here, but electrons will fill in an empty orbital first to not repel each other, because if this electron was located here, they would have to repel each other, but if it goes here, they wouldn't. So that is one way for the electrons to minimize the repulsive forces. And you always have to draw all the orbital boxes that belongs to a sublevel, so even though no electron is located in the last 2p sublevel, you would still have to draw it because there are 3p sublevels. So for the practice, lithium, its electron configuration would be 1s2 and 2s1. And to draw the orbital diagram, you would have to draw 1s and 2s, and you need 2 electrons for the 1s orbital, and you would only need 1 electron for 2s because you only have 1 electron in 2s orbital. And magnesium, its electron configuration is 1s2, 2s2, 2p6, and 3s2. And its orbital diagram would look like this: 1s, 2s, 2p, 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 and then 3s. You would need to fill in the orbitals all fully because each orbital contains all 2 electrons in this case.